the atoms are mostly neutral. Okay, they are not ions. The positive charge is at the center and negative charge is surrounding the positive charge. But if you apply an electric field on it, if you apply some electric field in this region, let us say in this region, electric field is on this side. So electric field will try to separate the negative charges and the positive charges. And when that happens, a single atom, which was assumed to be spherical, has now a distorted shape. The center of positive charge has now moved to one end, and the center of negative charge has moved to the other. So because of the application of external electric field, the positive and negative charges are a bit separated by a small amount. It's not like that all the charges separated, they're still attracted to each other, and that's why they are holding each other. But the electron and proton, the center of the charges, it was like center of mass earlier, the center of charges is separated now. So this results in a phenomenon which is very common in nature, that is formation of an electric dipole. Formation of an electric dipole is because of application of electric field. So a single atom can have its own dipole. In chemistry, you like to write a delta negative charge and delta positive charge. What about covalent molecules? Similarly, you can say for covalent molecules like HCl, the chlorine likes to keep the electrons. The chlorine likes to keep the electrons. So there will be a delta negative charge on the side of chlorine and a delta positive charge on the side of hydrogen. So here we see the positive charges and negative charges are separated by a small distance in each of this atom, which was initially neutral. Later also it is neutral, but the charge is separated. And this can also happen in molecules like molecules of water. There is a delta positive charge on the hydrogen, delta positive charge on the other hydrogen, and delta negative charge on the oxygen atom. So to draw, when we draw water molecules, we like to draw it like this. Means there is a distorted shape and there is a delta positive charge here. You can write delta plus plus and delta minus minus charge like this. So here also the positive charges and the negative charges, they are separated by a small distance. So this is found very common in nature whenever you apply electric field to any object, any substance. So it tends to behave like this, and this quantity, the separation of positive and negative charge, is termed as electric dipole. So we'll draw a very simple diagram. Take a negative charge, take a positive charge, and they are separated by a distance. And let us take that distance to be 2L. We are taking 2L distance because it will help us in calculation later on. This charge is minus Q, this charge is plus Q. And we like to take the direction of 2L from negative charge to positive charge. What that means is we'll define a quantity known as P vector, which will give us the property of the system. So there are two things in this system. First are equal and opposite negative and positive charges. Okay? Equal and opposite charges. So first I will write that charge is a scalar. Then I need a direction. because dipoles have direction from negative to positive charges. The reason for that it will come. So Q into 2L vector. So direction of dipole moment is from negative to positive. So direction of dipole moment, direction of dipole moment. What is dipole moment? This quantity is called dipole moment. Dipole moment is a property of electric dipole, and this system is called electric dipole. Direction of dipole moment is from negative to positive. Of course, before this, we need to define what is an electric dipole. So you must have guessed it quite from here right now, that an electric dipole is a pair of equal and opposite point charges which are separated by a short distance. I'll define an electric dipole is a pair of equal and opposite charges. I should write point charges. That will be more accurate. Equal and opposite point charges, which are separated by a short distance. Now, this is the definition of electric dipole. So, this atom, when electric field was applied to it, it became an electric dipole. HCl is a natural electric dipole. HCl acts as a natural electric dipole. Same goes for H2O. H2O molecule is a natural electric dipole. And all these systems have a property called dipole moment, which is a property of the system because it depends, the dipole moment depends on two things. First, the charge and the separation between them. So this quantity is called dipole moment, defined as product of charge and the separation between the charges. That is the definition of a dipole. Any questions?
Sir, in electric field, uh, the moment is from positive to negative, right?
Yeah.
Sir, so why in electric dipole it's from negative to positive?
So see, if you place for right now, you can say that it is a convention, negative to positive. This is the direction of electric dipole moment. Because when we apply external field, the external field is from, it separates the, when we apply external field to this atom, the negative charge moves towards the left, the positive charge moves towards the right. So this dipole moment basically shows the direction in which electric field was applied. So people have designated the direction of dipole moment like this, from negative to positive. Okay. Later, it was known that dipole moment is a property of a system itself, not the external electric field. It's the property of system itself, and that convention stuck. Any
Thank
other
you, sir.
questions? Next, we are going to find electric field due to an electric dipole. And there are two cases for it. First, we'll find electric field on the axis of the dipole. So we have two charges, plus Q and minus Q. They are separated by a small distance. A small distance, let us write it as 2L. And whatever electric field that will calculate it from the center of the electric dipole. Let us say from the center of the electric dipole, the point where we want to calculate electric field is x distance away. So this distance is x, and at this point we want to calculate the net electric field. So if this is 2L, I can write this distance as L, and this distance is also L. And from definition, our P vector is Q into 2L vector. See, net electric field, we can write it as net electric field is electric field due to plus Q plus electric field due to minus Q. So electric field due to plus Q, if we calculate, we can write this as 1 by 4 pi epsilon naught, charge on plus Q charge is Q, and see distance of point P from Q, this total is distance is x, this much distance is L, so this much distance will be x minus L. This will be x minus L. So I'll write this as kq upon x minus L whole square. And the direction towards right, I will take it as positive. That is electric field due to plus Q at point P. Next, you want to find electric field due to minus Q, and the direction of that will be towards leftward, in the left direction. So I'll deliberately add a minus sign here, or you can just write a plus here, then 1 by 4 pi epsilon naught into minus Q upon x plus L. Because distance from P to the charge Q, it will be x distance plus L distance. So it will be x plus L square. Rest is our calculation. So let us take 1 by 4 pi epsilon naught and Q common. So here I will get 1 plus 1 over x minus L square, 1 over x plus L square. This will be cross multiply. So x plus L square minus x minus L square whole divided by x minus L square, x plus L square. So this will give you 1 by 4 pi epsilon naught. You do the calculation, x square plus L square, x square plus L square will get cancelled. Here it will be 2Lx, and here it will be minus 2Lx, but there is already a minus sign. So that will give you 4Lx. Whole divided by, see this is a plus b, a minus b, a plus b. So I can write this as x square minus L square whole square. That is the net electric field. I can write net electric field as 1 by 4 pi epsilon naught into Q into 2L. I will write Q into 2L because I know Q into 2L is our dipole moment, into 2x whole divided by x square minus L square whole square. Any doubt in the calculation? I hope not. If you have, you can ask. All right, we'll move forward. Now we have electric field due to an electric dipole on the axis. This line is called the axis. This line is called the axial line or the axis. We'll carry on this formula to the next page. Now, suppose your point P is very far away from the electric dipole. If point P is very far away from the electric dipole, I can write x is much, much greater than L. If x is much, much greater than L, then this implies that x square is very high compared to L square. And this would imply that even if you add x square or subtract L square from x square, it will be approximately x square only. Think of it as like this. Your L is in millimeters. Your L is in millimeters and x is in centimeters. If L is 1 millimeter or 0.1 centimeter, if this is 0.1 centimeter and this is 1 centimeter, so x square minus L square is 1 centimeter minus 0.01 centimeter square. That is 0.99. 0.99 is approximately equal to 1 centimeter square. Just giving an example that if L is very small, very far away from the point P is very far away from the electric dipole, your x square minus L square will be approximately equal to x square. This is the approximation that we are going to use here. And we're going to reduce our formula. So E net when x is much, much greater than L. So E net will be written as 1 by 4 pi epsilon naught into Q into 2L into 2x. So I'll write it as 2x. And x square minus L square is x square only. So this will become x to the power 4. So I can write this as 1 by 4 pi epsilon naught into the x and x will cancel. This will be twice of q into 2L whole divided by x cube. Now, if you pay attention, this P is equal to q into 2L. The dipole moment is equal to q into 2L. So I can write E net will be equal to 1 by 4 pi epsilon naught twice of the dipole moment divided by the x cube. 1 by 4 pi epsilon naught 2p by x cube. Okay, and unit of electric field is Newton per Coulomb. There is another catch of this convention, that we take the direction of dipole moment from negative to positive. So my dipole moment vector is along this. My P vector lies along this. And net electric field is also in this direction. E net will be in this direction. So you see, direction of electric field and dipole moment vector, they are the same. Means if I want to write P vector, that will be equal to Q into 2L vector. So direction of the L vector or the dipole moment vector is the same as electric field. That is a result that we can use here. So electric field due to an electric dipole on the axis of the dipole x distance away is 1 by 4 pi epsilon naught 2p vector upon x cube. Unit will be Newton per Coulomb.
Sir, I didn't understand from second step.
This x is much, much greater than L. So what we have here, See, we have a point P here. The point P, I'm taking it much far away from the center of the dipole.
I understood.
This you understand? From here, what I'm doing, just instead of x square minus L square, I'm putting x square. Just tell me which step did you not understand?
Sir, that E net is equal to 1 by 4 pi epsilon naught q into 2L 2x by x by 4.
Okay, this one. How this became this. So instead of x square minus L square, I'm writing x square. So that means I can write x square minus L square whole square as that will be approximately equal to x to the power 4. We follow this step. So that we can put here. X square minus L square to whole square is x to the power 4. Is that clear now?
Yes, sir. And after that, how it x raised to 4 becomes x raised to 3.
Because x and x gets cancelled. There is an extra x in the numerator. This x and one of the x will get cancelled. Any other questions? All right, we'll be moving ahead then. This was electric field on the axial line or on the axis of the line. Any other questions? Okay, let us move ahead. Now, next we are going to find electric dipole moment or electric dipole at a point on the equatorial line. Electric field on the equatorial line of a dipole. First, do the geometrical construction. Two charges, first is minus q, second is plus q. They are separated by a distance 2l. And equatorial line is a perpendicular bisector to the L vector. It's a perpendicular bisector to the L vector. So we'll take a point here on the equator. So this gap is L. This gap is L. And I'll mark this point as A, B. The center is O, and this point as P. Now, Q will give electric field at point P along the line but away from the line. Along the line PB, but away. While the electric field due to minus Q, the negative charge, will be towards it. Let us call this electric field as E1 and this electric field as E2.
Hello?
Yeah.
Hello?
Yeah.
Sir, we can't hear you.
Sir is disconnected.
It's disconnected. Am I audible now? Please tell me if I'm audible now.
Yes, sir, you are audible.
Yes, sir.
So see, I was saying that electric field due to this plus Q charge will be along the line which is away. Along the line PB, but away from the charge. But due to this negative charge, it will be along the line AP, but towards it. Step by step, we'll write the electric field due to E1 and E2. Pay close attention. So this is E1, this is E2. And I want to find the distance between P and B. I will take this distance as, let us say, R. This distance is R, the distance from O to P. So I can write my PB, distance PB will be R square plus L square. From Pythagoras theorem, root over R square plus L square. And this will be equal to PA. PA will have the same length, root over R square plus L square. And also later, we'll be needing this angle, So I'll define it as theta, this angle theta. If this angle is theta, then this angle is also theta. And this angle will also be theta. And this angle will also be theta. Because this is the same line, and this angle with the horizontal with the line is, angle of this line with the horizontal is theta. So angle of electric field with the horizontal will be theta. And for this, these are the alternate angles. This theta and this theta, they are the alternate angles. So I'll be needing cos theta later. So let me write it beforehand. Cos theta is base, that is L, upon hypotenuse, that is R square plus L square to the half, power half. Any questions up to here? Okay, let us now write the value of E1 and E2. So E1 will be written as 1 by 4 pi epsilon naught into charge is Q, and the distance is PB. So PB ka square is R square plus L square. That will be the direction of electric field. If I want to write E2, that will be, value of E2 will be, just talking about the magnitude because I have already shown the direction. So 1 by 4 pi epsilon naught, same value, Q by R square plus L square ka half ka square, that will be the same thing as R square plus L square. Now see, I want to find the resultant of two vectors. So I will do it by the component method. I'll do it by the component method. So there are two equal vectors, E1 and E2. So I can take component along two directions. Component along two directions. So E1 component along here, it will be E1 cos theta. And component along this side, it will be E1 sin theta. For E2, component along the angle, component along the line with which theta is attached will be E2 cos theta. That E2 cos theta will get added up to E1 cos theta. While component along the other line, it will be E2 sin theta. Because this angle is 90 degree, this angle is 90 degree, I can take component along these vertical and horizontal lines. Now we know that E1 sin theta will cancel out E2 sin theta. So E1 sin theta and E2 sin theta will cancel each other out. But the E1 cos theta and E2 cos theta, they will get added up. We can write this as, because E1 is equal to E2, I can write this as 2 E1 cos theta. So net electric field will be towards left direction and the value is 2 E1 cos theta. Okay, any questions here? All right. Now, I will calculate the net electric field as 2 E1 cos theta, and that is towards left, from left to right. Sorry, from right to left. So I will write the net electric field E net is equal to twice of E1 cos theta. So E1 is this value. I will take E1 from here. That will be 2 into 1 by 4 pi epsilon naught. And cos theta is, sorry, E1 is Q upon this thing, into cos theta. Cos theta, I'll pick it from here. L by R square plus L square to the power half.
Sir, in E2, it will be 1 by 4 pi epsilon naught into minus Q, no?
No, I
E2.
have already shown the direction here. So you don't
Yes.
need to write a negative sign. I've already specified the direction towards the charge.
Okay, sir.
So here also we'll do some approximation. So I will write this as 1 by 4 pi epsilon naught. The numerator C becomes 2QL or Q into 2L. Seems familiar? And denominator is R square plus L square to the power 3 by 2. Power 1 plus power half will be added up to get power 3 by 2. So this is your net electric field on the equator, and we can write this as the net electric field like in the vector form. 2QL is P divided by R square plus L square to the power 3 by 2. That is the net electric field in terms of dipole moment, and that is only the magnitude. If I want to write the direction, I know my dipole moment is from left to right. That is my P vector. And electric field is from right to left. So direction is opposite. So what I can write here, I will write a negative sign and I will put vectors on this. I know the magnitudes, but the directions are opposite. So I'll put a negative sign. And that is electric field on the equatorial line of a dipole.
Sir, I didn't understood from E net is equal to 2 E1 cos theta.
So see, use your pen and notebook. Actually substitute the value of E1 and cos theta. Put the value of E1 from here and cos theta from here. Do that.
Yes, sir, understood.
Understood? Okay. Now again, we'll do the approximation when the point is very far away from the dipole. I'll take this equation and we'll do approximation. So when the point P is very far away from L, this implies that R is much greater than L. This implies that R square is very high value than L square. Then this implies that R square plus L square, that will be approximately equal to R square. Means adding up L square to R square doesn't change it by a significant amount. It's like adding 1 millimeter to a meter. Adding 1 millimeter to a meter is 1.001 meter. Doing this square, that will reduce it down to even further smaller amount. So that's why we write r square plus l square is equal to approximately equal to r square. So if I put this value, I'll get E net is equal to minus 1 by 4 pi epsilon naught into P vector. R square plus L square becomes R square to the power 3 by 2. This will give me the net dipole moment on the equatorial point as 1 by 4 pi epsilon naught into P vector upon R cube. This is on the equator. This is the result. And if you compare this result and the previous result, it is the electric field on the axis is double than that of equator. I'll write here magnitude magnitude of electric field on a point far away from dipole is double on a point is double on the axis than that of equator, which is same distance. And direction of electric field is opposite. Direction of electric field on the axis of a dipole is opposite to the direction of electric field on the equator of dipole. And unit of electric field is Newton per Coulomb. So, are there any questions related to this? All right, we'll move on
What
to the
is
next topic.
equator?
Equator as an equatorial axis. You can write here equatorial axis.
Sir, can you show equatorial axis in any of the diagram?
This was the equatorial line here. This is the equatorial axis or equatorial line. This perpendicular line. That perpendicular bisector of the dipole is equatorial line. After this, we are going to study how how dipole behaves in an electric field. For that, first we need to learn what is a uniform electric field. Anybody remembers what is a uniform electric field? Uniform electric field from the previous classes. So for uniform electric field, the magnitude and direction of electric field remains constant. The magnitude and direction of electric field remains constant. Such type of fields are known as uniform electric fields. So they are drawn by parallel lines which are equidistant from each other. Parallel lines and equidistant from each other. They are represented by parallel equidistant lines. And we can give it a value E, or you can write E. That is a uniform electric field. While a non-uniform electric field, the magnitude can vary, the direction can vary. All the electric fields which are not uniform will be called non-uniform electric field. Both the magnitude, direction, or magnitude and direction individually can vary. That will be called a non-uniform electric field. So we have to study what happens when we keep an electric dipole in a uniform electric field.
So could you please scroll up?
This one?
Yes. Yes, sir.
Okay. So next topic is a dipole, right? Electric dipole. Later we will come to know that there is a magnetic dipole also. And the properties of those are very similar to electric dipole. So I'll write electric dipole in a uniform electric field. In a uniform electric field. So if you keep a charge in an electric field, the charge experiences a force. That force is given by Q into E. Let us say electric field lines are from left to right. They are uniform, call them E. And you have an electric dipole which is tilted a bit like this. This is the minus Q charge. This is the plus Q charge. And the distance, this distance is 2L. Now, if I write the force on this, so force on the positive charge particle will be in this direction, and the value will be QE, Q times E. While force on the negative charge particle, it will be in the opposite direction. Amount will be the same, QE. So we see net force on dipole is 0. Net force on dipole is equal to QE minus QE. The forces are in opposite direction, so net force is 0. But there is a torque. There is a torque on this, and we'll try to calculate the torque. To calculate the torque, I can calculate torque about the negative Q charge, or I can calculate torque about the positive Q charge. So let us calculate torque, net torque about minus Q charge. that will be equal to force into perpendicular distance of the force from the charge. So I'll have to calculate the perpendicular distance of the force from the charge. So I'll extend this line and I'll drop a perpendicular from the axis, that is from the minus q charge. So I have to measure this length. I have to measure this length. If suppose angle between the dipole moment and electric field is theta, theta is the angle between dipole moment is like this, and electric field is like this. This is P vector and horizontal is E vector. Angle between them is theta. Angle between two charges is theta. So angle between the two vectors is theta. Right here, theta is angle between dipole moment and electric field. So torque will be written like as force into the distance between the force and this. So the distance will be this distance. If this is theta, I can write this angle as theta. If this is theta, this is 2L, this whole length is 2L. So this length will be 2L sine theta. Because again, it's the right angle triangle. We're taking component of 2L on the perpendicular. Of course, this length will be 2L cos theta because angle is attached to this. But on the opposite side, the length will be 2L sine theta. So I can write the net torque about it as force into this distance is 2L sine theta. The value of force is QE. So it will be QE into 2L into sine theta. And you can see the torque will try to rotate it in the clockwise direction. Torque will rotate in the clockwise direction. About minus charge q, will rotate in the clockwise direction. So direction is clockwise. Any questions up to here? Okay. Now, so I can write the torque is equal to QE into 2L. So I'll write this as E into Q into 2L into sine theta. And direction is clockwise. I'm saying the direction. Instead of doing that, I can write it in vector form. This is my torque vector. This is my electric field vector. And this is my dipole moment vector. Okay, before that, let me write another step. Q into 2L will be dipole moment. This is E. This is sine theta. Now, this is sine theta. So this is a cross product. Torque is a vector quantity. I can write this as P cross E. Right? Why should I write P first and E later? Because it is P vector cross E vector that will give you the clockwise direction. If you do E vector cross P vector, it will give you anti-clockwise direction. So I should write here P cross E. And this gives us the result that whenever an electric dipole is placed in a region with uniform electric field, a torque will act. A torque of magnitude P cross E, and direction will be represented by the P cross E, and unit will be Newton into meter. So magnitude of the torque can be also written, that is torque is equal to PE sine theta. So if theta is equal to 0, torque will be equal to 0. So if direction of magnitude, direction of dipole moment is same as electric field, then torque is 0. If theta is 180 degree, then also torque is 0. Here, in this case, dipole moment and electric field, they are parallel. While in this case, the dipole moment and the electric field, they are antiparallel. And if theta is equal to 90 degree, torque is equal to PE. This is the maximum torque. This is the maximum torque. Here, dipole moment and electric field, they are perpendicular to each other. Any questions?
Sir, if theta is 180 degree, then P and E are in opposite direction.
Yeah. P vector is like this, and E vector could be like this. Any other doubts?
No, sir, I am just noting them.
Yeah. Note it down.
Done, sir.
Okay. Okay. Before moving on, see, theory-wise, this was it. That is all the theory that is in the first chapter. But I presume that you must have tried questions in this chapter. And if you have tried and faced difficulty, let us discuss that first. If you have questions or doubts from the book, any statement from the book that you haven't understood, we'll discuss it now. If not, I'll be giving you questions from my own.
Sir, I have one question in
Yeah.
textbook.
Yeah, you can mention the question.
Sir, in short answer type question number 6, I didn't understood why we took the derivative of force by Q.
Okay. So this is question number 6 from short answer, right? So if you calculate the force in that, I'll just read the question for other students also. So a charge Q is there, and this charge Q is divided into two portions, such that they repel each other. If this charge is divided into two portions, let us take the first part as Q dash. So the other part will be Q minus Q dash. And it is said that they are separated by some distance. All that distance R. And what they want to do, they want to maximize the force between the charges. Okay, so find Q dash such that electrostatic force is maximum. Electrostatic force is maximum. Other students mention, remember, this is the question. Find Q dash such that electrostatic force is maximum. Now, without giving any bigger thought, I can write the electrostatic force between them will be 1 by 4 pi epsilon naught into Q dash divided by R square. Not Q dash, but Q minus Q dash. Okay, so here see, this force is a function of Q dash because Q dash can vary. The distance is something that you have chosen. Q is something that you have that was already given. So Q and R are constant. 1 by 4 pi epsilon naught is a constant. But the variation is in the Q dash. So this becomes a function. You can write this as Q square minus 2Q Q dash. Q dash Q. Q dash Q into Q dash square. So Q dash is a variable. Now, here we are going to use a concept from maxima minima, from calculus. So, do you know the concept of maxima and minima? If there is a function that you have to maximize or minimize, what we do is we differentiate it with respect to the variable and equate it to 0 to get maxima or minimum. Have you heard about this concept?
No, sir.
Okay. So if
Ye-
suppose,
Yes, sir.
okay, you have heard about. So I'll just give a small introduction to this because it is very crucial in other parts of physics also. I'll give you a small introduction. So I'll just do you know derivative gives slope of a graph?
Yes, sir.
Okay, so dy by dx gives slope of the graph. So if you have a function like this, and at any point you draw tangent, at any point you draw a tangent, if this angle is theta, then we can write at this point dy by dx, at this point, let us call it point A, at A will give you the value of tan theta. And this is called the slope of the graph. The value of tangent at any point of a graph, this is your y is equal to fx, this gives you the slope of the graph. I'm explaining it in short. If you want more details, then you please revise the application of derivative portion. Was it in 11th standard? That this topic, application of derivatives, mathematics.
Well,
Okay, it is in 12th. So remember this, dy by dx gives you the slope of the graph, and this is tan theta. Now suppose you have a graph like this. A graph like this, here tan theta is always positive. Tan theta is always positive. So at each and every point, you will have a positive slope. And the value of differentiation at any point will be positive. While in other case, this is your x-axis. I'm not drawing y-axis. It's not required. You can take y-axis anywhere. On the other hand, if your graph is like this, if you draw a slope like this, then theta is greater than 90 degree. Theta is greater than 90 means tan theta is negative. That means slope is negative. So this is called an increasing graph. If slope is positive, then graph is increasing or value of y is increasing. And if slope is negative, then this is called a decreasing graph. So here value increases if tan theta is greater than 0, slope is greater than 0, and here slope is decreasing. To give an example, let us take an example. Suppose I write y is equal to x square. And have you studied the equation of a parabola, how to draw this? Apoor? Equation of a parabola, how to draw this?
The equation of a parabola is y is equal to 4x, right? No.
So y is equal to x square is the equation of a parabola. Is one of the equation of parabola, not the general equation. This is the x and y axis. If I calculate my dy by dx, its value will be 2x. Now dy by dx will be greater than 0 if x is positive. You can see if you put x as positive, this implies that slope is positive. So for x greater than 0, graph is increasing. But if x is less than 0, then dy by dx, here see, dy by dx will have a negative value. So for x less than 0, graph is decreasing. And this thing is apparent from the graph also. See, for negative values of x, when you increase x, value of y is decreasing until it reaches 0. After 0, the slope becomes positive, so graph keeps on increasing. Is it clear?
Yes, sir.
Okay. Any questions up to here?
No,
All right.
sir.
All right. Now, what if this was increasing and decreasing graph? But suppose our graph is like this. So here the graph is increasing, here the graph is decreasing, but at this point, the tangent is horizontal. Tan theta is 0. Tangent is horizontal. When tan theta is 0, that means dy by dx is 0. So at the maximum point, this point will be called a maximum. If it's a hill, this point will be called a maximum. This is your x-axis. While in the other case, suppose graph is like this, then here again the tangent is horizontal. So tan theta is 0. So dy by dx is again 0. This is your x-axis. So this point represents a minimum. So a maxima can be identified as if first graph is increasing then decreasing. Means before the maxima point, let us call this maxima point as x0. Before the maxima point, slope was positive. After the maxima point, slope was decreasing. If something increases then decreases, then means it reaches a maxima point. And if something first decreases, then increases, that means it reaches a minimum point. But at both the points, to identify x0, you have this situation that dy by dx is 0. At both the points, dy by dx is 0. So what is the approach that you should take? You should first identify your function y as a function of x, then find dy by dx. That's the second step. Then third step, find points for which, find the values of x for which dy by dx is 0, and put those values in y is equal to fx to get maximum or minimum value. These are the steps. For example, suppose I will give you a simple example. If y is equal to, is defined like this, 2x minus x squared. This is also equation of a parabola. So this function is already given. So dy by dx, you will find dy by dx, that will be 2 minus 2x, or 2 into 1 minus x. Then you will find the value of dy by dx for which, value of x for which this is 0. That will be for when x is equal to 1. So when x is equal to 1, we can put the value here. This will give you the value as 2 minus 1 equals to 1. So if you put any other value like 0 here or any other value, it will be lesser than that. You put 3 here, that will be 3 to the 6 minus 9, that is minus 3. So this is a maximum. Even if I give you an example like this, suppose force is a function of distance. So some constant 1 by 4 pi epsilon naught into q into 2r r naught 2r minus r square. Let us say the function is like this. So I can differentiate my function df by dr. The constants will stay like that. That is 2 minus 2. Next step is to equate it to 0. 2 minus 2r is 0 when r is equal to 1. When r is equal to 1, you can find the value of maximum. This will be again the point of maximum. So x is equal to 1 is the point of maximum. And when you put that value in y, you will get maximum value. Any questions up to here?
No, sir.
Okay. Going back to our original question, I want to do df by dq dash is 0. So df by dq dash, this constant will stay like that, 1 by 4 pi epsilon naught into r square. Differentiating with respect to q dash, so it will be q minus two q dash. Then equate it to 0, you will get, for this to be 0, the denominator cannot be 0, the numerator should be 0. From here you will get q dash is equal to half of the charge. And when you divide the charge equally, then you get your force as maximum.
Yes, sir. Understood. Yes,
Okay.
sir.
Any other student? Any other questions?